Hi, friends. Welcome to the Tamiki Ergonomics Podcast. I'm Matt Jeffs. In this episode, we return to speak with Professor Emeritus in Human-Centered Design at Cornell University, Dr. Alan Hedge. In what follows, Dr. Hedge explains a more nuanced understanding and application of the OSHA Hierarchy of Controls. We'll discuss its applications, its misapplications, and its implications. Remember to click the notification bell to keep up with the best in ergonomics knowledge sharing, and feel free to leave a comment below. Also, be sure to subscribe and share this and future episodes with colleagues and clients who can benefit from this valuable information. Now, join us as we listen and learn from a pioneer and statesman in the field of ergonomics, Dr. Alan Hedge. Welcome back to the Tamiki Ergonomics Podcast. I'm your host, Matt Jeffs, bringing again Professor Emeritus from Cornell University, Dr. Alan Hedge. How are you, Alan, today?
I'm very well indeed. How are you, Matt?
Good, thank you. Joining you from sunny Florida. I'm up north east coast, and you're down south, aren't you?
Southwest coast, yep. Yeah, it's beautiful, very nice and warm.
Yeah. We've had a nice cool spell while I've been down. Today, we wanted to talk about the hierarchy of controls, but I understand before we get into the history of it and what we can glean from it, you wanted to lay some groundwork. So could you give us a little bit about how the groundwork for ergonomics may help predispose us to how we might look at and use the hierarchy of controls?
Absolutely. Yes, I mean, the hierarchy of controls that we're going to be talking about is dealing with issues in jobs where things are going wrong. Okay?
Right.
But what we've got to remember is, and going back, in fact, to our first podcast, ergonomics is the science of work. And in the beginning, that meant that ergonomists were actually involved in designing jobs. And if you design a job and design it appropriately, you can pretty well say the hierarchy of controls might become irrelevant because you've done a good job in designing it. And we have to think about designing jobs as being pretty well the same as designing any kind of product or system. So in the beginning of ergonomics, people were talking about the science of work. But what is work in our terms? If you think of it, when you talk to somebody about work, you ask them, what work do you do? They're going to tell you what job they do. So we actually compartmentalize work activities into units that we call jobs. And then within that job, what is it that you really have to do? Well, in ergonomics, we break the jobs down into what are called tasks. And we've developed over the years a number of methods to analyze the tasks. And you can think that you can improve a job by reorganizing the tasks, resequencing them, eliminating some, introducing others, right? And so these task analysis methods are out there, and we have to always remember that. But you can have a task. A task tells you what activity, mental or physical, you need to do. To be able to do that well, you also need skills, and we've talked about skills before. So along with task analysis methods, we have a whole range of skills analysis methods. And you can have a really well-designed job with really great tasks. And then you can have a person who has the wrong skills do that and completely mess up. Okay, so we always got to remember that, what we're going to be talking about here with this hierarchy of controls, these are not controls in terms of controlling how a system works. These are controls in terms of controlling the risks that exist in a job. But often those risks are because the job wasn't well designed or the person didn't have the necessary skills to be able to do that job in a safe way. And we also need to remember there's one other dimension to this that used to be a big part of ergonomics. It's become a little less so these days, and that's personnel selection. In other words, you may have a job that's well designed. You may have tasks that are clearly identified. You may know the skills. You may have a skilled individual, but they may be the wrong size or even the wrong shape. And you may say, what am I talking about? Well, we've just had the Kentucky Derby, right?
Yes.
What does it take to be a jockey? How many jockeys are built like basketball players? There's not
Right.
many. How many basketball players are built like jockeys? Yeah, not many, right?
Even
So,
less. Yeah.
so when you start to think about jobs, you have to think about a whole range of other factors. And so, the hierarchy of controls, as we'll get into the details, tends to assume that everything is kind of uniform. You have a worker and you have a job, and the two go together. It's a lot more sophisticated than that. And not only that, but going back to the early 1950s, you have to think about what was then called the FITS list. This is FITS, F-I-T-T-S, after Paul Fitts. Paul Fitts was one of the founding figures of human factors and ergonomics in the USA, and he was working with Wright-Patterson Air Force Base. And he developed this FITS list that essentially said, what is it that people are good at, and what is it that machines are good at? And so if you're going to design a job that is
Yes.
truly the most effective, you've got to optimize taking what people are good at with what machines are good at. And so he produced, I'll give you, this was his famous FITS list here, which, you can download off the web. But I'll just give you some examples. He said, people are really good at detecting small amounts of visual or acoustic energy and recognizing patterns in light or sound. It's even though we have great technology now for detecting the physical aspects of this, it's still not that easy for machines to actually recognize patterns in sound. And let me tell you what I mean by that. I may say something to you. I may say they are eating apples, right?
Mhm.
Now, what does that really mean? If you analyze the words, it means that either there are objects out there that are called eating apples, or people are engaged in an activity of eating an apple. And how do we figure out which is which? Well, we use all kinds of subtle cues, including nonverbals, and we put things together. And you can watch any sort of detective series program and see how humans get to be pretty good at taking apparently disconnected parts of information and putting it together and recognizing a pattern. And sometimes it's a real pattern and sometimes it's a fake pattern that we believe in. But to this date, machines are still not quite as good at that. But the things we're pretty bad at are doing anything that requires a lot of strength and effort, right? Or
Yeah.
repeating the same thing perfectly time and time again.
Right.
Really hard for us to do that. Machines are much better at doing that. So going back to the 1950s, ergonomists were involved then in trying to figure out how do we design effective jobs, recognizing that most jobs involve human beings interacting with technology. And if you get that wrong to start with, then you're going to have problems down the road. So you could say that if you really want to do away with OSHA's hierarchy of controls, there's only one way you can do that, and that is don't have people doing jobs. Have machines doing jobs, because machines don't get injured. They may break down, so they're not perfect, but they're not going to be occupational injuries. So I just want to set that context that we shouldn't forget that this hierarchy of controls is really about sort of patching up what's been done in terms of a bad job in how we design work. And think about your own work as an ergonomist. You often are called in to a situation to try and improve the situation. How often are you called in to design that situation from the get?
Right.
And if companies realize that, then they'd have a lot fewer problems at the end of the process because the process will be well designed from the get. But no, we're often sort of the afterthought of when things go wrong, calling the ergonomist, and hopefully, when you come in, maybe you can't actually resolve the issues because the job wasn't well designed to start with. So, I'll get off my hobby horse now about the importance of ergonomics, but we mustn't forget that what we're dealing with here is the fact that ergonomics should really be an upfront endeavor in terms of designing work rather than a sort of afterthought in terms of trying to recover from errors that have been made in job design.
this age-old discussion of leading indicators versus lagging indicators, and we're so the ounce being worth the pound of cure. You've just described for me, without me even realizing it until you went through that, some of the things that always bugged me about the OSHA hierarchy of controls. And I tried to trace it back. The earliest I could find was National Safety Council, 1950, calling it the hierarchy of controls, and then the OSHA Act here in the U.S. in 1970 adopting it, or sometime thereafter.
Right.
But without editorializing too much, since you're really making some very salient points here, uh, you know, sometimes when I discuss this with audiences and groups and things, I'll explain, if we look over the past 40 years, to your point about elimination,
Mm-hmm.
we've seen how some have used that to send operations to other parts of the world where they don't have to worry about labor problems or environmental
Right.
problems or safety problems. And so that wasn't the highest and best use of that principle. And even in recent years, we're seeing the outsourcing of just problematic departments. So there are online companies, for instance, who will remain nameless, who use vans, but they subcontract the vans out, so they're not liable for auto accidents and things like that. And so that inverted pyramid, that hierarchy, looks great on paper, but it can be applied many different ways, can it?
Yes, it can. So just so that our viewers, listeners know, I mean, here is
Yes,
the here is
there
the
it is.
pyramid, and hopefully that's going to be made available. And of course, I mean, it is an inverted pyramid. You really almost should think of it as the iceberg again, because most of what we do
Right.
is down underneath. But the top thing says elimination, remove the hazard, physically remove the hazard. Well, who designs a job that physically has a hazard in the job, right?
Good
How did
point.
that happen? And
Yeah.
I mean, yeah, if you say, okay, what you were talking about is the second level, which is substitution, replace the hazard. Well, you've sent the hazard somewhere else. You
Right.
haven't really improved the design of the job in some way,
Nope.
shape, or form. And so that's really what we as ergonomists should be trying to help companies do to create a better job. So you could
Yes.
say eliminate the hazard. If people don't do the work, there is no hazard. But as soon as you put
Yes.
people in the system, you introduce hazard. Why? You can have the most skilled person in the world, but we can't repeat things perfectly day and night, week after week after week. And it's not just physical work, it's mental work as well. And you
That's
know
right.
yourself. I mean, we all make mistakes. To err is human. If that's
Right.
part of work, that could be a catastrophic error that could lead to, say, a nuclear incident, things like 3 Mile Island or
Yeah.
Chernobyl or Fukushima, or it might
Right.
just be a trivial thing. You typed the wrong thing. We just had this in Florida. We just had an emergency alert go out in the early hours of the morning, like 4:14 in the morning. That went to everybody's phone, which blasted out, woke people up, scared people like crazy. Why did it go out? Well, because somebody actually selected the wrong option in the computer system. And instead of it going out in test mode, it went out as the real thing, you know.
Wow.
So, I mean, that things
There
happen.
it is.
People make mistakes, right? So we have to think about that. And again, that if you go back to ergonomics, looking at the design of jobs, the design of work, there's a lot of work done on that, particularly in very high consequence industries like the nuclear industry or aviation. I mean, you think all the work done on how can pilots make errors. We should
Right.
devote the same level to looking at everything else, because we also have many examples of things where people, typed the wrong information in or chose the wrong variable in a software system, and that led to a catastrophe. We had runs in the financial market going back into the 80s and things that happened because of user error. Right?
Yes.
So yeah, elimination sounds great, but the only way you can truly eliminate, if you want to eliminate it globally, is don't have people involved.
Yeah, and then what do we do? Yeah, with that
Well,
idle time.
yes.
Um, you go
What
ahead.
the important thing I think for people to remember is this: the hierarchy of controls, where essentially you're controlling risk. You're controlling the risk of the consequence of something going wrong, right? You often won't know that there's a physical hazard until people have been exposed for long enough that we have the evidence to know that it's a hazard. A simple example, right? Asbestos exposure,
Yes,
right?
yes,
Now, you can go back in history and find that the Romans knew that when they put people in asbestos mines, some of them didn't live as long as they might have done. And back in
okay,
the day, right, back in the day, remember, most of these people were not Roman citizens, but they were actually slaves who'd been bought or paid for or captured from battle or whatever. And they gave them face masks to wear because they found if you wore a face mask, it took longer for you to die than if you didn't, because you weren't breathing in asbestos fibers, right?
right,
What
right,
happened? I mean, it took 50 years before we had enough evidence that a regulating system declared asbestos a hazard. And
wow,
yet it's still out there, and we still think of cigarette smoking and the risk of
right,
developing lung cancer. So, elimination sounds great. You can eliminate the hazard, but you have to know something's a hazard. And often it takes time for the injury or in a horrible situation, the fatality to occur. Um,
right,
I mean, if you've seen the movie Erin Brockovich, right?
right. Yeah,
You'll know there with the hexavalent chromium in a water system. It took time for that. I met her and we talked about this a while back. And she was then working on a new hazard, trichloroethylene, which was used as an industrial degreaser and solvent. And now it links to a whole variety of health risks, including cancer risks. So often we don't know about the hazards very well in advance. And unless you have a system in place to monitor the consequence, it can take sometimes years before that happens. You're now seeing it with the adverts on TV for Camp Lejeune, right? If you were
yeah,
in the military and you were in Camp, or Agent Orange, these kinds of
yes.
consequences where the things happen. So yeah, elimination sounds great, but normally it's impractical.
Pre- Precisely, yeah. And the hierarchy again, if I'm allowed to beef a little,
Sure.
it's a little two dimensional. It quite literally is two dimensional. And um, as I've often when I teach my colleagues how to help out in this field, I'll often explain to them once you've identified a hazard, its root cause, go through the hierarchy of controls and try and see if you can solve it at each level. And the reason I would tell them is that's a good exercise. Number one, a mental exercise. You know as well as I do, so many who are first initiated to our field look for the silver bullet. And
Yeah.
there's got to be a silver bullet for that. And I try to explain to the people I work with, that's not always the case. So the hierarchy gives you 5 lenses to look through, and they tend to have a budgetary weight to each one as well. And that's when it dawned on me, wait a minute, we might be able to look at these from a timeline perspective. In other words, so many businesses, they just don't have blank checks. They can't just say, let's just eliminate it. Here's the 7, 8 figure check. They may be able to get there in a year and a half through budgetary process, but what are you going to do until then? And I started thinking about the hierarchy laying on its side and saying, you could build, plus each a level, when combined with others, becomes cumulative. So I wonder if you could share a little bit in your thoughts and experience with the pros and cons of each level. And if there is a way to look at this more as a continuum as opposed to one versus the other. Can you expound on that?
Well, sure. So again, let's just go back to the level so people know what we're talking about here. Right? We've talked a lot about elimination and the
Right.
fact that that's a problem. mean, the next one, substitution, sounds it's a good idea. Yeah, okay, you replace something that may be potentially hazardous with something that you don't think is potentially hazardous.
Right.
Let me give you an example there. Let's say cigarette smoking, and you replace it with vaping, right? Because you go, oh, now, so there's no smoke particles. We now
Yeah.
know that with popcorn lung, in fact, that's brilliant. You've replaced one problem with another problem. So you really have to be very careful about that. The
That's
key,
right.
from the standpoint of job design, what many people want to do is the third level, engineering controls. Aha, we have an unsafe piece of machinery, so let's put a guard around it. Or, let's give somebody let's make sure that there is a lockout system so that,
Right.
if somebody puts their hand into this dangerous piece of machinery, the system won't work. And that sounds great for some of the time,
Mm-hmm.
but not always.
Right.
Think of, well, in fact, a very recent example, and unfortunately a fatal example, just this past week, a woman who got burnt to death in her car,
Oh no.
right?
Yeah.
Because the car, it started, the electrical system, I don't know the details, somehow shorted out, right? Starting a fire. And of course, once that happened, the electric windows didn't work.
Of
The
course.
electric door locks were locked. She couldn't get
Yes.
out of the car, and before she could get out, the whole thing went up in flames, right? So you got to be really careful about your engineering controls and figure out how good are those controls, and are they giving you the right kind of information?
Yes.
We have a number of instances, particularly in aviation, where people have ended up doing what they thought was the right thing, but because the system was giving them the wrong information.
Right.
One classic example was a French airliner where people were controlling it that gave you a warning that the plane was going into a stall position because you got an audible warning up to, I think it was about a 25-degree incline, and then the warning stopped, right? And so they're pulling back thinking,
Yeah.
wow, thank goodness. And in fact, it stopped because the programmers had assumed no one would ever go beyond there. And the plane carried
Wow.
on and then just dropped out of the air into the ocean and everybody died. So, we
Yeah.
have to be very, very careful with the engineering controls. And we tend to think, engineering controls will solve everything. If that worked, then, you wouldn't have autopilot accidents with Tesla cars or other vehicles or things,
Right.
And you have to
Right.
make sure that whatever your engineering controls are, that they themselves are foolproof and
Yes.
will not work appropriately. We were earlier on talking about hurricanes. And we have a local
Right.
example here that people parked their cars in a local garage that had waterproof doors. And this is in a condo facility. Great. And so
Yeah.
we got storm surge, water came, water did not get into the garage. But after about 20 minutes, something tripped a fire alarm. And when the fire alarm goes off in a garage, all the doors automatically open.
Yes.
And when,
Yes.
of course, as soon as they opened, the whole garage
In
was
comes
flooded.
the water.
So
Oh,
you have to think through the work system and think, what could go wrong? And this
so,
again is where a lot of the task analysis, job analysis work really comes into play.
yes.
Back in the day, I mean, when I was doing ergonomics in the UK, if we were working on job design, we actually trained to do the job. These days, typically a company thinks, call in the ergonomist, they'll ride in, they'll solve the problem and go away. No, you had to learn how to do the job. We had people working on air traffic control, spent 6 months learning how to be an air traffic controller. Not that they were ever going to do that, but to know what the risks were and how to do engineering controls. And we've had a couple of examples recently of close encounters on airport runways where planes have almost crashed because of some issues in the system. And you could say, well, that's not a repetitive motion problem, but it's a cognitive ergonomics. What people
Yeah.
think they're doing, right, And sometimes
Yeah.
people think they're doing the right thing. That turns out to be catastrophically the wrong thing to do at that time. So again, this is where sometimes this hierarchy of controls isolate people from the hazard. That only works if you truly can do that. We recently had a train derailment where there was a lot of concern about environmental contamination.
That's
By
right.
the time you could isolate people from that hazard, they may already have been exposed, right? So you have to be
Yes.
really careful how you use this. Typically, where you and I would get called in is at this lower level here, because we're seen as cheaper and easier, administrative controls, right? I want to spend a little bit of time on that. Let's look at the lowest level, which is personal protective equipment. All right.
Right.
So somebody could be exposed to noise, give them hearing protection. Somebody could be exposed to a nasty chemical, give them a respirator or personal protective clothing. You've already seen what the reaction was when we said, if you don't want to catch COVID, block the virus by wearing a face mask. Right?
Right.
And wearing respiration. If that
Yeah.
were an occupational hazard, in fact, the people wearing it, working in the virology labs, are wearing personal protective equipment. They're well
Right.
protected. But,
Yeah.
people in the public say, I can't see any risk. So how often do you see workers who have their personal protective equipment, but their hearing protection is not over their ears, or their
Right.
face mask is pulled down below their nose, or
Yeah.
whatever, right? Because they
Yes.
don't realize that not all hazards are easily visible or detectable. And if you're exposed to loud noise, you don't immediately go deaf unless it's really, really loud, but you
That's right.
will over time with that
That's right.
exposure. So we're
Yes.
usually called in here for the administrative control. And that
Right.
usually means, okay, how do you reduce the risk of injury to people who are doing repetitive motion tasks? This
Yep.
is where methods like the methods we've talked about before, ruler, Reba, the NIOSH lifting equation, become useful because we can estimate the risk when we watch a person doing that job, and we can then suggest some alternative ways of doing that to reduce that risk.
Right.
But usually that also requires effort. It requires that people change their behavior over time. And
Hmm.
I'm sure you've experienced this. You can go in and you can show somebody, this is a better way of working at this task, of doing it. And they'll go, oh, yes. And while ever you're there, they'll do it that way. And as soon as you've gone, they'll go back to doing it the way that they first learned, right? And it
That's right.
happens all the time.
Yeah. All the
So you
time.
have to just think in this hierarchy of controls, they have it. Unfortunately, they say these are the least effective. Well,
Yes.
you've got to say, wait a minute. Actually, this is where most people in the world are.
That's a
These
good
are the
point.
most effective if
Yes.
you do things appropriately in terms of reducing risk. But you have
Right.
to be able to analyze it appropriately and then determine a good strategy to intervene and put a process in place that continuously reinforces that strategy.
There it is. That process. I'm a bit of a lean continuous improvement geek, so I'm unabashedly a proponent of that. But you're right. You have to have something that perpetuates. That isn't the flavor of the month. And I just, for instance, just this past week, did a tour of a place that I'll be doing some work for here in North Florida, where all of the mechanics wear mechanics uniforms, but they're fire resistant, FR. And you
Mm-hmm.
know what? That stuff doesn't breathe. And when you work in the hot Florida heat and humidity, you find, just as you're describing, shirts undone and untucked and things like that. And it's hard to blame people if they've got a hard job they've got to do and exert themselves in these conditions. I circle back a little bit to that silver bullet idea that,
Mm-hmm.
just give them this gadget, give them this doodad, and this will solve everything. But you made another important point that I'm often telling colleagues as well. I'm talking to my colleagues and I'll say, you've really got to think several steps ahead, because in ergonomics, it is easy to create three problems solving one. And like you described, you come up with an engineering, this is going to do it. This is the silver bullet. And then, your example of, the poor lady in the car, which also here in the Sunshine State, we have a lot of roadways over waterways, and sometimes cars go off those roadways into those waterways, and sometimes those electrical systems shut down and nothing's opening. And meanwhile, a car is sinking. And so these are real scenarios that have to be thought through.
Absolutely, they do. You also have to think about the fact that, when you go into, and I'm talking about, say, you personally you're called in to a situation where somebody is at risk of an injury, and you'll do your analysis, and maybe you can give them better product. I mean, I said earlier on, product design is related to this. So think of that fireproof clothing. It's really a product design issue, and people are not going to change their behavior to become less comfortable. They'll become more comfortable. But the fact is that at some point, that individual may shift jobs. They may quit. And now a new person comes in, and who is there to actually take them through that same process? So that's why you have to have a process in place. You need to have good risk analysis methods in place to analyze the risk before those risks become major issues. But you also need a process in place because your employees are going to change over time. Some of them may get ill, right?
Yes.
You may be dealing with a shift system. So it's a different person doing that job at night than in the daytime. And that shift system also may rotate. So different people will do those shifts over time. So you need to look at that whole system. I think, early on we talked about the fact that ergonomics takes a systems view of work. And you need to look at that, because if you don't, you end up trying to put a Band-Aid on a job. And when things change, that Band-Aid falls off. But I'm sure you've often seen that. You'll put a Band-Aid on and then you go maybe, in a swimming pool and the Band-Aid says it's waterproof, but it drops off. Things. You don't want Band-Aids. You need to, and unfortunately, the hierarchy of controls, particularly when they say that what we're talking about is least effective, it sort of dissuades anybody from taking it seriously and thinking, wait a minute, how do we design the most effective work system to maximize the performance of people while we minimize the risk of an injury or an accident or an incident?
Well, yes. And again, I think when I was referring the cumulative effects of these controls as they're adding up one next to the other, I think the word I'm groping for in a lot of cases, and we see this as we're called into different workplaces, the word is culture. And what is the culture of the place? Is management going to take your concerns seriously, or is it a top-down, old command and control style of leadership, or is it more collaborative? And all of these things play into it, because it circles back to what you always say. And ultimately, we're talking about people here, and everything.
Yes, we are. And you would hope that people in a company would realize the value of that. I mean, the other thing about the hierarchy of controls is that it doesn't really do a good job of telling you how to identify the hazards.
Right.
Now, I mean, some hazards pretty straightforward, and they may be short term. You've got a machine with a huge sort of razor that comes down like this. If you put your hand in, it's going to chop your hand off your fingers or whatever. On the other hand, maybe you say, gee, this is great. So we'll put a different kind of blade and we'll put guards in, and now the machine does it and you can't chop. We've solved the problem. But when that machine comes down, it might be making an impact noise that's 93 decibels. Over time, that person is not going to chop their fingers off, but they're going to lose their hearing. So again, You have to think about all aspects of this particular task in this particular job and look at how you can improve that over time as well. And I think a lot of times hazards get identified kind of in the wrong way. I'll give you another example, right? So the NIOSH lifting equation, it was great. We have this equation, we can predict. There are all kinds of limitations on it. I'm sure at one time we'll talk about those, but we can predict, what is safe lifting. So now you go and check in at an airline and say 50 pounds, your bike going 50 pounds. Well, it depends, because you then have to look at what are people doing with that 50 pounds. How are they lifting or manipulating that? Are they doing a one-handed lift, a two-handed? Are they really twisting are they trying to throw these bags on and off a conveyor? Have you been inside an aircraft, particularly one of the smaller regional jets, where you're manually trying to cram these pieces, supposedly safe weight pieces of luggage, into the back while you're in a very contorted posture?
Yes.
And so again, we have the illusion of safety, but not the reality of safety.
Well,
and when you look, a lot of people are still getting injured not because of the 50 pounds, but because of how the whole system has been designed to get those objects into the back of an airplane.
Exactly, or the bottom of an airplane. Exactly.
Or the bottom of an airplane, however they are storing. Yeah.
Yeah, and I still I love the example you gave of back when you started, you had to essentially apprentice for the job for a while to really get a sense of it. It's one of the things that I've always loved, and when again, I'm coaching someone and they want to get some experience without actually being able to get out and get experience. Forgive me for suggesting it, but I will often recommend they look at old episodes of Mike Rowe's Dirty Jobs. And I'll say, watch that and try to assess what that pig farmer has to do or that person has to do. Use freeze frame. And I've often described myself as the Mike Rowe of my field in physical therapy, because you find yourself in these settings, and that's the nature. He describes that show as he's a perpetual apprentice. He's a perpetual first-time employee. And as you point out, there's nothing like feeling the heat of a commercial kitchen or hearing the noise of impact drivers in a commercial auto shop, or the fumes of a commercial welding lab. And, there's no substitute for that, is there? I mean, that's really, then you become something more, I think.
So I totally agree. And one of the things that one should always try and do is look at this concept of skill that I keep coming back to, because it's fundamental. If you can take a really skilled person and look at how do they do this job, and then look at how does a novice do it. Now, this is what happens in athletics, right? This is why we have coaches. So you look at a skilled tennis player. How does somebody like a Djokovic serve the ball compared to a novice? And then you say, now we can video them. We can slow that down. We can see exactly what's happening there. And let's try and emulate that and figure out how do we train people to get to that level of skill. So again, that becomes important for every kind of job. Even if your job is just you're given a shovel and your job is to shovel something up, whether it's snow or mud or whatever. Believe you me, there are healthy ways of shoveling and there are risky ways of shoveling. So the key here is going back and figuring out how do the experts do things, and then how do we train people who are novices so that we can do that. And that's where the process comes in. If you look at what happens in sports, we've developed very sophisticated ways of taking novice school kids and turning them into professional athletes if they have so-called talent. And talent means they're the right size, they're the right strength, or, they got the right reaction times to be able to do something. We need
Yes.
that same approach to when we're looking at everyday jobs, because if you don't do that, it would be like us trying to have professional sports teams where you just go on the street and you choose 20 people and say, hey, come and play this sport. It will be
Right.
chaos. And
Yes.
yet
Yes.
that's often what we see, because it's not usually the people who are most skilled who get injured. It's because they're most skilled that they don't get injured.
Good point.
So you look at most jobs and it's actually the people doing the more menial aspects of the job, working at a cash out register or stocking the shelves, not the people who are doing, looking at spreadsheets to figure out, our monthly sales, or how do we organize, how do we optimize, the flow of good, whatever it is, how do we optimize the route that our delivery vans are going. Those are not the people who are often getting the most injuries. So it's really important that companies look at themselves and say, wait a minute, who's my best employee? Who's been here the longest? Who really knows how to do this? And they may have figured a way around doing something that is better because they've removed the risk that was associated with how people thought you should do that job. And then take what they've done and then come back and apply that to other individuals.
Understood. To summarize our discussion in the moments we have remaining, how would you suggest this is foolish to say the average environmental health and safety person, but I'll use it, or ergonomist, as just a standalone for a moment. How would you recommend one utilizes the OSHA hierarchy of control, if at all? I mean, is there an application for it that you think, for instance, when we discussed REBA and RULA, you explained, well, remember, this is a tool that helps us with relative risk. Don't think it's absolute. Is there some kind of approach to the hierarchy of controls that has that higher level of sophistication you're describing?
I think so for the health and safety person, because if you really look, as we've talked about, in the hierarchy of controls, elimination of the risk, right, should be done at the level of designing the job
Yeah.
that's going to be done, right?
Yeah.
And maybe so it's pretty bad job design if it's taken you 5 years to realize most people are getting injured. So where the health and safety person has to start with is by looking at what data do we have.
Right.
What do we have data that shows that more people are getting injured doing this job than doing a different job, or doing
Right.
this task in this job than doing different tasks? The second thing is talk to employees. What do they find is the hardest thing to do? Right?
Right.
Most employees can tell you, well, this is the bit that I hate the most. Why do you hate it? If you hate it, you're probably not going to want to do it and do a great job. So if you think of the hierarchy of controls, most health and safety people are already down at the level of administrative controls, because the other issues should have been ironed out of the system before you get to that, right?
Yeah.
And most manufacturers are not going to make equipment where they know that they have known risks in their equipment. So if you,
Right.
make a chainsaw, you're not going to have a chainsaw that doesn't have any kind of sensing mechanism, so that if you're not chopping through metal or wood or whatever you use, it doesn't stop pretty well immediately. You've got lots
Right.
of built-in safety things there. So most health and safety people are at the admin controls level, and that means you need really good risk analysis tools. Let's forget about the personal protective equipment, because that's a subset of those are environmental risks that you're dealing with,
Right.
mostly. Unless it's something like, a vibrating hand tool where maybe you need vibration absorbing gloves. But most of the time you're dealing with occupational exposures to gases or fumes, or, something that's noxious, or noise or whatever. So the admin controls are where you're going to have the greatest impact. And that means looking at how do really skilled people do this who aren't getting injured? How do novices do this? And this is where having tools like Ruler and Reba, the NIOSH lifting equation, observational tools where you can go in and watch how people are doing the job, you can pretty well see where in that job is the greatest risk? What movements are the riskiest movements? What tools are the riskiest tools to use? What takes the longest time to do? And are there ways of changing how you design things so that you remove that risk? So, for example, if somebody has to reach down and pick up a screwdriver to then perform a task, is there a way that you can, suspend the screwdriver so they just have to grab it and use it? And that eliminates in that particular part of the job that risk. So that's, I think, where most health and safety operations are going to have the greatest success. And even though it's labeled in the hierarchy as one of the least effective, it's also the least costly, and it's going to affect the most workers. That's where most people are. But you also have to think sensibly. And let me take just one other example. One of the things that started to become popular in healthcare, because human beings don't have nice grab handles on them, and because most human beings weigh more than 50 pounds, right? Hospitals can't be like airlines. And so team lifting has become, yes, this is what we'll do. We'll teach people to team lift a patient or somebody who's fallen on the floor. Well, first of all, most individuals, if you're an adult, are likely to weigh 150 pounds or more.
Easy.
So if you team lift, that means each person potentially has 75. You're already over. You wouldn't be allowed to do this with an airline, or you'd put an extra heavy label on. The second thing is, who's the team? If you have one person who is 5 feet tall and one person who's 6 feet 6 tall, there's a greater risk than if two people are 5 feet 6 tall or whatever.
That's right.
So how do you teach them? How do you max that? Do you train them at all in lifting technique? Do you have something in place where you allow them time each week to do upper body strength training, or you teach them lifting techniques, or you allow them time in a gym or whatever, right? There are lots of things you have to think about. And it's very easy for companies to say, oh, yes, we've eliminated that. We use team lifting. We use, we label everything that weighs more than 50 pounds. Even with 50 pounds, if that's an asymmetric load, and if that's a one-handed operation, and if there are no nice grab hands, you try lifting up a plastic bag that's full of 50 pounds of water.
Oh, yeah.
Without handles. Right? I mean, you have to be very sensible about analyzing the situation. So look at what tools we have, what methods we have, and use those. Ergonomics is really very valuable when you apply good analysis to that situation.
I'm so thrilled every time I get a chance to speak with you like this, and to hear, again, the multidimensional approach you bring to these two-dimensional things like the OSHA hierarchy of controls, because again, I'm right there with you. I see so much value in administrative controls, and yet it's down there near the bottom. And I'm thinking, what are you kidding? And you're also singing my song because I'm a 30-year doctor of physical therapy, and I've had the 250-pound patient's knees buckle, while all I have the hold of is what's called a gait belt around their waist. And your initial instinct is, I'm not letting this person go to the floor. And so suddenly you're suspending 250 while you're calling a 100-pound nurse over to help get you to this person to a chair. It's a very real scenario that happens all the time. And you're right, there are no handles.
That's true.
Well, Dr. Hedge, I just so appreciate these. I know our listeners and viewers do as well. And I hope we can have you back for more of these discussions as we work our way through all the different elements of ergonomics we find out there and scratch beneath the surface and really see what's there and what isn't, so that all of us can be a little more sophisticated in our application. Can we enjoy you back on another episode?
Absolutely. Look forward to that.
Well, it's always a pleasure. And so we'll talk with you on the next one. So on behalf of Dr. Hedge, I'm Matt Jeffs. This is the Tamiki Ergonomics Podcast. And remember, work smarter, not harder. We'll see you next time, everybody. Bye-bye. We hope you enjoyed this episode of the Tamiki Ergonomics Podcast with Professor Emeritus in Human-Centered Design at Cornell University, Dr. Alan Hedge. Remember, click the notification bell and keep up with the best in ergonomics knowledge sharing, and feel free to leave a comment below. We do read your comments. Also, be sure to subscribe and share this and future episodes with colleagues and clients who can benefit from its valuable information. On behalf of the Tamiki Ergonomics Podcast, I'm Matt Jeffs, and remember, work smarter, not harder. See you next time, everybody. Bye-bye.